All right, so let's describe the motion of this object in words. This is some in-class practice that we did. And starting with part A, it goes, whoa, come on, goes forward for 2 seconds, stops, and goes back for 4 seconds. I'll say stops for 1 second and goes back for 4 more seconds. All right, now the velocity between 0 and 2 seconds, again, we get this using a slope calculation. So v is going to be x2 minus x1 over the time that passes, using the rise over the run. So I would use 4 minus 0 over 2 minus 0, and that gives us 2 meters per second. The velocity between 2 and 3 seconds is 0 meters per second. Let's actually show that. I can actually read the graph here and say that it's 4 minus 4 over 3 minus 2, which is 0 over 1, which is 0. And then the velocity between 3 and 7 seconds. Let me actually slow down and do this calculation. I'm going to do one of these calculations. So here I am at 7, 0. And here I'm at 3, 4. So when I actually get the velocity, that's going to be 0 minus 4 over 7 minus 3. And that actually ends up being negative 4 over 4, which is negative 1 meters per second. All right, now when we plot the velocity versus time, I don't actually like the way this graph is set up. There really should be sort of a mark here rather than this axis down there. The reason being that I'm going to actually end up getting, for the first 2 seconds, a velocity of 2 meters per second. So, and then for 1 second I stay stopped. And then from 3 to 7 seconds, 4, 5, 6, 7 seconds, it ends up being, it's just like 2 seconds, 4 seconds, 6, and then 7 seconds right here. It ends up being negative 1 meters per second. So that's the first page. And then here we want to plot these velocity graphs. Once again, when we have a position graph and we want to plot the velocity graph, we just want the slope. So for here, we get a slope of 1. Here we get a slope of 1 and then negative 1. And let's be clear on how I'm getting this second one here. So when I calculate, this is 2, 4 and 0, 2. So for this first part here, I get the slope as 4 minus 2 over 2 minus 0, and that's 2 over 2, which is 1. And for the second part, here I'm at 0, 4. So when I get that slope, it actually ends up being 4 seconds and 0. So this ends up being 0 minus 4 over 4 minus 2, and that gives me, in fact, negative 2 meters per second. So let me make a little adjustment here and drag this down there like that. Wow, good thing I did that. All right, and then for number 3, it's similar to number 2. I thought it was kind of interesting that people got a little lost on the difference between 2 and 3, and that tells me that I need to be a little bit more mindful when I'm going over stuff. Because as a physics teacher, I see these as very similar problems with numbers changed, whereas when people were going over it, it really threw them off. So I'm going to go through this one a little bit more slowly. So this point is 1, 2, and this point is 0, 0. So let's get the slope. For this first part for 1 second, that's going to be 2 minus 0 over 1 minus 0, and that's a slope of 2 meters per second. So that's the first second. Okay, that's cool. But then here, I'm at 5, 4 at the end, so when I get the slope here, that's going to be 4 minus 2 over 5 minus 1. That's 2 over 4, which is 0.5 meters per second. So for the remaining time, I would actually draw a line halfway down, like at a half. So this is how I would make that graph look. Okay, so that's the velocity graphs. And then we got a couple questions. So it says, what does the slope of a position graph tell you about the motion of the object? It tells you the velocity. And the way you could also say that is a speed and direction. Okay. And let's just remember that negative means backwards and positive means forwards, okay? What does the area under the velocity time graph tell you about the object? how far it goes, how far it ends up from where it starts. Okay, and then we're going to actually use the displacement graph and the velocity graph to check and make sure that that works. So for example, here, the displacement is where I end up from where I started. So I started at 0 and I ended up at 4, so my displacement is 4 meters. Now, according to the Buggy Lab, extension lab, mini lab that we did, if I get this area here, my width is 4, my length is 1. 4 times 1 is 4 meters. So that also works. Now here, I started at 2 and I ended up at 0. So my displacement ends up being 0 minus 2, which is negative 2 meters. Now let's get this using the area. So this length is 1 and this width is 2. So the first rectangle, I get an area of 1 times 2, which is 2. But then we have this second rectangle worth of area, and the length is negative 2 and the width is 2. So when I get that area, it ends up being negative 4. And when I add these two areas up, I end up getting a displacement of negative 2. In other words, I ended up 2 meters backwards from where I started. Similarly here, I started at 0, ended up at 4, so my displacement is 4 meters. When I use the area to help me, this width is 1 and this length is 2. So I have 2 times 1, which is 2. But then here I have a length of a half and a width of 4. So I have 2 plus 4 times a half, which is 2 plus 2, which ends up being 4 meters. So whether I use reading it off the position graph or I use the area, both ways get me the displacement. So here, when I actually have this graph and I'm going to describe the motion of the puppy over the interval shown, I would say here moves forward for 2 seconds, then back for 2 seconds, for 1 second, and stops. If I had to describe this in real life, it's like think of like you got a puppy and then you pretend to throw something, and so the little dude's like, that's a really bad drawing of a puppy. So what ends up happening is that it runs this way, and then it's like confused right here, like it runs forward, and then you fake throwing it, and then it like runs back and like winds up here. And then it kind of just stops and looks at you, like right here. Then when we calculate the displacement of the puppy, that's going to be the area. So that's going to be 4 times 2, which ends up being 8 meters. So that's the practice that we did in class. And I think that wraps it up pretty much. Yes, I did have you plot the position versus time. This is a great graph for us to be doing. And I will actually label it here so we can actually say, let's see, 1, 2, 3, 4, 5 seconds, right? So 1 second, 2 seconds, 3, 4, 5, that's time and seconds. And then here, I'm going to need to go fairly, so let's see, 1, 2, 4, 6, 8, 10. That's cool. So 2, 4, 6, 8, 10 meters. So when we plot here, we can start at the origin. Let's just start at the beginning of the ruler. Here's the idea. We're saying that the slope is 4 for 2 seconds. So I go over 1, up 4, over 2, up 4, and I end up at 8. I then go backwards for 1 second at 3 meters per second. So in the next second, I need to wind up at 5, and then I stop. So that is my displacement versus time. So those are the practice problems that we did in class, and I'll post that on Haiku right now.